Good morning everyone. Today we will talk about exploratory software development style. So exploratory software development style is the style of development. Generally this style is used by student and junior programmer. So in this style what actually happens is we don't use any method or engineering approach to develop the software. What we will do is we simply use our intuition to write the code. So first we will do the કોડિંગ કે સૌથી પહેલાં આપણે શું કરશું કે પ્રોગ્રામની ડેફિનેશન પ્રમાણે ડાયરેક્ટલી વી વિલ સ્ટાર્ટ ઓન ધ ઇનિશિયલ કોડિંગ. Then we will run the program. ડાયરેક્ટલી આપણે શું કરી કે સૌથી પહેલાં કોડિંગ કરશું, ત્યારબાદ એને રન કરશું. જો પણ એક એરર મળે, if you found any error, so we will fix the error. અને પાછું શું કરશું આપણે રન કરશું. And if any error found, we will solve the errors. So this will be a cycle. So process the cycle until no error are found. And then stop when there is no bugs. So it will be a final code. So this style is known as the initial exploratory software development style. કે સૌથી પહેલાં શું કરીએ આપણે ઇનિશિયલ કોડિંગ, then રન, અને જો એક કોઈ એરર મળે તો એરરને આપણે સોલ્વ કરી અને પાછો રન કરશું. આના ડિસએડવાન્ટેજ શું છે? તો આના ડિસએડવાન્ટેજ એ છે કે જો પ્રોગ્રામ નાનો હોય તો this style is okay. If the program is very large, it is not suitable for large project. So for large project, it is not suitable. લાર્જ પ્રોજેક્ટ માટે આ સુટેબલ નથી. વાય? તો આઈડિયલી શું થવું જોઈએ? એક એક્ઝામ્પલ લ્યો કે દેર ઇઝ અ વોલ, કે સિમ્પલ એક દિવાલ છે. જો હું તમને કહું કે બિલ્ડ ધીસ વોલ, તો યુ કેન easily build the wall with your basic knowledge. What you need is some cement, some bricks, etc. And you can build the wall. But if I tell you I want to build some building, I want to make the multi-story building, then what will happen? You can't simply use your intuition to build this type of building. So this approach won't work on the large scale. So same thing will happen on the software side. If you have many small definition, you can directly use this style. But if you want to develop a large project, you cannot use this approach. Because in the large scale, If the program size increase, it generally increase the complexity. For example, there are so many variables, so many methods, etc. And it will be difficult to remember for the human brain. So if you want to say scientifically, what will happen is, what we want ideally. For example, if I want to write 100 line of code, for example, it is taking me 10 minutes. So what should be the ideal situation is, if I double the program size 100 to 200, so it should take me 20 minutes, because if the program size increase, the time will be increased linearly. And if I make it 300, it should be 30 minutes. This will be the ideal situation. Something like, if there is a machine who are writing the code, it will do something like this. If I double the program size, time will increase by the double. So it will increase linearly. But it is not possible with this style. What will happen is, my time will grow the exponentially. What exponentially means is, for example, for the 100 line, I am taking 10 minutes. But if I double the program size, so instead of 20 minutes, it will take me more than 20 minutes. For example, 25 minutes. And if I increase the program size by 300, what it will do is, instead of 30 minutes, for example, it will take me 40 minutes. So it is not growing linearly, and it is growing exponentially. So if I make the chart, what will happen is, for example, this is the chart. This is the time on the y-axis, and x-axis there is the program size. And this is the time to develop the software. This should be the ideal situation. As the program size is increasing, the time will increase linearly. But in case of our exponential style, for the small program, it will be okay like the ideal situation. But as the program size increase, the time will increase exponentially. See how it is going up and up. My program size is not getting double, but time is getting up more and more. So at the point, it won't be possible to develop a program. So this is like a machine, and this is our time. So for the large project, this style is not suitable. So that's why we should use the software engineering techniques. Software engineering techniques provide the engineering approach to develop the software, so that our time will be near our ideal situation. So these are the disadvantages that we can't use this software for large project. And also, the quality of this software will be very poor. Even if you develop the project using this style, the quality will be poor in this software, and it will be difficult to maintain, and it will be difficult to upgrade or enhance. this is the our today's topic, exploratory software development style. Our next topic for the revision is SDLC or software development lifecycle. So SDLC is the process used by the software industry. It is used to design and develop the high quality software. So if we want to develop the high quality software, we should follow some process which is defined by the SDLC. SDLC consists of detailed plan describing how to develop, maintain and design the software. The life cycle defines the method for improving the quality of the software and overall development process. The SDLC is divided into these steps. First step will be requirement gathering. સૌથી પહેલા what we need to do is first we will need to gather the requirement from the user. Then next step is feasibility study. After the feasibility study, next step will be design. After the design, it comes with the coding. After the coding, there is a testing. Then testing, then deployment. And maintenance. And again it will connect to requirement gathering. So this is the whole process of SDLC life cycle. The first is requirement gathering, feasibility study, design, coding, testing, deployment and maintenance. Now let's see one by one phases. The first phase is requirement gathering. So requirement gathering means to collect requirement from user. So whenever we want to develop the software, first what we will need is the requirement of the user. So what user want to develop or what functionality user want. So we can collect the requirement in many ways, like we can use interview, we can use survey, we can use questionnaires, etc. The first thing we will need to do is requirement gathering. And after the requirement gathering, there is a feasibility study. In the feasibility study, what happens is whether the software is feasible or not. Feasible means it is possible to develop or not. It is checked. So in the feasibility study, what we will do is we can be the many type of feasibility study. Like first is economical feasibility. Economical feasibility means the software we are developing should be economically feasible or beneficial. If the software is not economically feasible, it is not used to we should not develop the software. And there is a legal feasibility. Legal feasibility means whatever we want to develop, it should be legally possible and it should not be illegal. For example, we can't make the software to hack someone's computer. It will be illegal. Then there is a technical feasibility. Technical feasibility means we should check whether the software is technically possible to develop or not. And last one is schedule. Schedule feasibility means we need to check whether the software is possible to develop in the given time or not. So this type of feasibility is checked before developing the product. If the software is not feasible, we should cancel the development of the software. After the feasibility, there is the next phase is design phase. Design phase is the producing the various type of document which will help in the next phase, which is coding. So there are two types of document, high level and low level. So in this process, what we generally produce is, we produce the SRS, system requirement, specification, and various other documents like use cases, ER diagrams, describe the database, etc. So these are the design documents which will be used in the coding phase. The coding phase is the actual coding using the some type of language and technologies. After the coding is done, what we need to do is we need to test the software. Testing means software is tested for quality assurance and to check whether all the requirement is met or not. So first, the testing is done to check for bugs, is there any error or not, requirement is complete, and quality. And if all the thing is checked, then the next part will be deployment. Deployment means install the software into client machine or client server. It is known as a deployment. And after the deployment, the next phase will be maintenance. Maintenance means when users are running the software or using the software, if there face any issues or bugs, we need to solve the bugs. It is known as a maintenance. Also, sometimes user can require some update, so we need to add some functionality or modify some functionality. It also comes under the maintenance. And if user wants some functionality, what we need to do is we need to again gather the requirement and make whole the process. So this is like a cycle which will comes in step by step process. So this is known as a software development life cycle. Hello. Our next topic will be waterfall model. This is the very important question for your exams as well. So waterfall model is the model of SDLC or software development life cycle. It is very simple and easy to understand and use. In waterfall model, each phase or step must be completed before next step begins. So it consists of step by step process which is followed step by step. and each step should be completed before moving to further next step. So this step are, first is requirement, gathering. First will be requirement gathering, next will be feasibility, next step will be design, after the design next phase is coding, and after the coding next phase is testing, and testing there is a maintenance. It is similar to like a waterfall which is falling down and down. So each step must be completed before moving to next step, and when we get to the one step we can go backward. It is something like waterfall which can go back. The first step is requirement gathering. The requirement gathering is the gathering the requirement from the user. It should be done the first thing. Whenever we want to develop some software, the first thing we need to do is we need to understand the exact requirement of the customer and document them properly. So after this step, what we will get is we can make a document like SRS or software requirement specification, which contain everything, every requirement of the user. Next step is feasibility study. The main aim of the feasibility study is to determine whether the software we are developing it should be financially worthwhile and technically feasible or not. Financially worthwhile means it should make some profit or beneficial. If it is not beneficial or don't make any profit, it is not worthwhile to develop the software. And also it should be technically possible. So we should check whether the technologies we have should be possible to develop the software or not. Then there is a design phase. All the requirement we have collected using requirement gathering, then we need to design the software using this type of requirement. So what we will do is we can use two types of approach. One is known as a traditional approach, and second is known as a object oriented programming approach. Traditional approach means it is known as a procedural, and object oriented means we can define the various classes and objects. So two approach can be followed to design the software. After the design, the next phase is coding. In coding, what we will do is we will divide the software in multiple modules, and then each module is coded using some programming language by team. After that, each module is tested independently. So first we divide the project into different modules, then each module will be coded in some language and each module will be tested. After the coding is completed, the next phase will be testing. So testing means the whole project is tested for bugs and errors. If there is any bugs or error, we need to fix the bugs and errors. Next, we want to check is requirement. We want to check all the requirement of the user is met or not. Next, what we need to do is we need to check for quality. So whatever the software we have developed, does it meet the quality standard or not? If all the things are checked, then we need to deploy and maintain the software. So maintain means you can use the bug fixes. If there is any bugs after testing, we need to fix the bugs in the maintain when users run the program. There are chances that he came across some bugs, or we need to enhance or upgrade the software. Means if the user want or modify some functionality, we can do it. So this type of model is known as a waterfall model. Each step is defined one goal. So first is requirement, feasibility, design, coding, testing and maintenance. And each phase should be completed before moving to next step. So this is known as a waterfall model. The advantage of the waterfall model is it is easy to understand. It will be easy to follow. It is very easy to understand and follow because every step is defined clearly, and it will help to develop high quality software. The disadvantage will be can't go back in previous phase. We can't go back to previous phase. For example, if we found that we are in the coding stage and if we found there is some problem in the design phase, if we do something wrong, it is not possible to go back in the previous phase. It is the main disadvantage of this model. So this is known as a waterfall model. I hope you understand it well. Hello everyone. Next model is prototype model. It is also one type of SDLC model like waterfall model. The problem with the waterfall model is all the phases are completed step by step and we can't go back to any phase. The problem is many times user want to do is he change the requirement in the process. For example, whatever requirement he have given, it will be changed. So after that, it is not possible to go previous and change the requirement. It is the main drawback of the waterfall model. To overcome this disadvantage, we have a prototype model. The prototype model is first what we need to do is we need to make a prototype. So what is the prototype? The prototype is generally a toy software or small scale software. The prototype is generally have a limited functionality and it will be unreliable. So before making the final product, final software, what we will do is we will make the one small program or small scale implementation of a system and it will generally have a limited functionality. For example, instead of multiple logins, we can use the one static login, and we can use the fake data or limited amount of data instead of real-time data. It is known as a prototype. The reason to use the prototype is it will help to understand about the client. It will help the client to understand the final project. Okay, using the prototype, the client will get the rough idea how my project will be. It will help the client to understand the project. So we can discuss and show the project to client, and client can give the suggestion that what are the changes he needs. So the final project will be more reliable and what the customer want. In the waterfall model, what will happen is sometime the client want is it will be different thing than the client. So what client expected, it won't be the software. So it will help the client to get the general idea about the final project. It will also improve the customer involvement in the project documentation or project development, unlike the waterfall model. It will also reduce the maintenance cost as final product will have a better quality. Because final product have better quality, and it will also have a less bugs, and so it is the main benefit of the prototype. And after the prototype is developed, we follow the same procedure, something like waterfall model. Like first we will design, then code, test, and maintenance. Also loop back is added, so we can go back and change something if there is a requirement for the changes. So this will be the advantage of prototype. Next thing is how we can develop the prototype. How to develop prototype. The prototype is developed by gathering the requirement from the user. First, gather requirement, and then develop whole scale software. Generally, prototype is a GUI like program, so it will make the client understand what will be the final project. So this is how the software is developed, and then all the waterfall model steps are followed one by one. If your prototype is okay, then we will design the software, then we will code, test, and maintain. It is not something like that. So final software is designed using the prototype. If the prototype is okay, the prototype is thrown away and actual software is designed using Scratch. the final product will have a better quality because your software development team already have some experience about this software. So next, whenever the software is developed, it will be of better quality. So this is known as a prototype model. It overcomes the disadvantage of the waterfall model.